This new lecture will be about the networking technology that allows you to split the same equipment into many virtual instances of the same equipment. And first I'd like to start with an example when I show you how this type of requirement can appear in pretty simple environments such as our lab environment. So what we do have right now in the lab basically is that we have computers that you see here, and they are installed in the room 2203. But what you don't usually see is that we have server farm which is installed downstairs somewhere in the
basement.
In the basement, and we have our services running there, and also there is a connection to the university networks, and all of this is basically serviced by the switches that you had experience configuring last week. So on the screen you see our current setup when we have our computers connected to the servers, and then the servers and the switches help us to connect to the internet. Why do we have such setup? This is because this is computer security lab, and at some point in time we had to run a lot of malware samples and other malicious software, and we wanted it not to be able to escape to the university basically, so we could cut this wire basically temporarily or constantly or monitor it. There was a lot of things going on, so this setup was designed to protect basically Binghamton University and the internet users from us. When we decided to make this computer security class, there was a question where to connect this class. Basically, we could have done it by connecting your switches to the university infrastructure directly, but in the future labs you will see several labs which are dangerous by themselves, and you can create some kind of denial of service attack on university infrastructure. So
yeah, we wouldn't want the university to send us angry emails saying something is coming from ports that you own, and it's bringing everything down.
So this is not a good example how to connect the lab. The second proposal basically was to connect the lab to our current computer security lab, to our lab environment, and this is not good because we wanted to keep the separation of the lab from everyone else. So stuff that we could have run will not end up on your flash drive and not on your home computer. So what we did is actually we kind of virtualized our switching equipment into double layers with a technology called VLANs. And what it allows us to do is to kind of create two switches out of, technically not two but many more, but in this
multiple
example,
switches.
In this example you see that there is a red network with the red switches, and there is a green network with green switches, which physically represent the same switch, and this helped us to keep our lab and the computer security class lab separate while using the same equipment. Very interesting concept that you should learn in this to understand VLANs is the concept of the broadcast domain. This is basically the perimeter where the packet that you send, the packet which is designed to be delivered everywhere, will be able to reach. So broadcast is basically you shout through the network as loud as possible who can reply to my request. And by design this packet should be delivered to everywhere where it is there is a cable or something like that. So
yeah, just a quick note on VLANs. This is a very important concept in this class. This isn't something that you can sort of skim over and it'll go away. This will keep coming up again and again and again. So if you have any questions after watching this or after doing the lab, please feel free to ask, because it's much better to ask now than later when we'll get frustrated with the question.
Many labs will rely on this lab basically as a first step before you continue with other things. So if you cannot do this in the first place, there will be many more steps that you will struggle with. So the broadcast domain. So imagine that, not imagine actually, the blue computer sends the broadcast packets to the switch, and as you can see, this packet gets delivered to every single host in the network where the switches are connected to. So as soon as the packet reaches the switch, it gets forwarded to every port available to the switch. And as you can see, this is kind of nice because with one packet you can request many computers, but when the network becomes very big, it becomes it basically manifests itself more like a problem than a useful feature. So what you can do is to control the way the packets can propagate through the network, you can basically tag them with the color. And this is not really how it works, but it is useful to think about it that way. So let's classify our computers into several colors, and let's say we want blue computers to talk only with blue computers.
So blue only to blue, red only
Yeah.
to red, and green only to green.
When the colored computer sends a packet, what we basically want to do is that any uncolored packet will be colored to certain color that we configured it on the switch. In that case, we configured it to color it into blue. And as we can see, when the packet gets forwarded, it can propagate through only the ports that already have like this blue square on them, which are configured to pass through the blue tag traffic. Again, we see one disappears and another one continues.
So to set something like this up, all of the configuration is done at the switch level. So the computers, while they may be colored certain things in this implementation, do not have any awareness of this setup at all.
Yes, so as you can see, the packet gets strip of color, and the original white packet is delivered to the server 1. As you can see, when the packet gets transmitted through the channel, you should notice that the blue should be configured on both ends of the channel. So if there is no blue in this end, switch will not allow it to leave. If there is no blue in this end, then switch will not allow it to enter. A lot of people forget this thing, especially in the later labs, that you need to configure both ends of the cable to be able to actually
Right.
transmit. So you should configure the switch to allow to leave the packet from the switch and to enter the switch, another switch basically. So yeah, and if you think about this like an abstract level, it turns out that you basically manage to configure the switches in such a way that you have 6 virtual switches which allow you to isolate traffic between red, green and blue networks.
So now no longer is every computer accessible in the broadcast domain. Now you've limited that domain only to the computers as seen here, the blues, the greens, and the reds. And
Yeah.
that's the whole purpose of this. It's to isolate and to divide networks.
And yes, it's not only about broadcast packets, because now if even blue computer tries to contact red computer, he will not be able to. It
Right.
will literally look like he has no physical connection to red networks. This implemented through extension of the Ethernet frame, and as you can see, there is a additional field was introduced, and it consists of the identifier of the 8021Q tag and basically some additional information, and the most interesting thing, VLAN identifier. This is technically the color, but in the implementation of the switches it is a
Number.
Yes, so 1, 2, 3, 4 up to 4096 I think, or 95. So you can have a lot of colors and you can divide networks any way you want. And
So for example, instead of having the red network and the blue network, you would have the 5 VLAN and the 6 VLAN, or the 3 VLAN and the 537 VLAN. So you could have up to, on a single switch, or on a whole network of switches, up to 4,000 different private switches, or VLANs.
And those VLANs basically don't really interact with each other, so you should treat each VLAN is some kind of virtual switch, which
Right.
spans several physical switches.
Right.
So when you connect something to this VLAN, the information can propagate through this VLAN, but it cannot move basically to another VLAN. That's the whole purpose of it. This is basically the summary of positive things about VLANs. First, the ability to limit the broadcast domains basically enhances security. This is because when you have a lot of computers, and there is a higher probability of one of them being exploited, subverted, or something like that. And when you have large broadcast domain, it means that the subverted computer has more targets to try to attack. If you have smaller domains, it's harder for the attacker to go to this computer undetected, because if you segregate your network into pieces, you can put firewalls and other special tools that will monitor all the traffic that crosses these domains.
So like let's say if you have 20 computers, but you have 10 that only need to talk to those 10, and another 10 which only need to talk to those 10, but you only have one switch. Those could easily be separated into two separate VLANs, and they don't need to talk to each other, so why should they? So when you separate them out, then you improve security that way.
I mean, technically you can organize their talk through the router, but this will allow you to monitor what kind of traffic goes between those tens and these tens.
Right.
If you don't do this, your switch does this direct communication, so you will not be able to observe such a thing. Another thing about which is good about VLANs is that you can use it to group users by their function. So if people sit at different places, but at the same time they belong to the same function in the company, something like that, you can join them into one network.
So like you could have a management VLAN that can span several switches across the building. So whenever someone who's in management plugs their computer into the port, then it'll add them to the management network, even if they're on the other side of the building and there's multiple switches along the way. As long as the management VLAN, whether it's VLAN number 7, number 10, as long as it's propagated the whole way, then they will all be on the same network.
Additional useful stuff about it is that instead of buying additional switches to isolate things, you can buy one switch and pretend that you have many. So you kind of increase networking, not equipment utilization. So you can fill all the ports on the switches. And yeah, that's nice. And I will talk about it in more detail later. Switches allow you to segregate the traffic by its properties, and this allows you to set up high availability or quality of services. Like you have voice networks that don't consume much traffic, but they need high priority. And then you have data traffic, which you don't care if it is delayed by 1 second, but you want most of the traffic to go there. And switches allow you to separate those things.
So before we start this is the important part. This part directly relates to what you'll be configuring on the switches.
Yeah, so we just talked about the VLANs, how the packets get colored, but as you noticed, there are these endpoints where the packets actually get colored, and it is important to properly configure those things. And now we will talk about different types of endpoints that you can have on the switches. And the first one is the access ports. These ports are usually used when you have a computer which is not aware of VLAN technology. So it sends the traffic which doesn't have this 802.1q traffic. There is no such thing in it. So the switch needs to insert such a field and tag the traffic with a particular VLAN. And in order to do that, you configure this special type of port called the access port, which takes in untagged traffic and puts configured tag. Like for example, in here you will put blue tag, and in reality it will be, for example, 3. Right? And as you can see, all the computers here, they have these access ports configured. The inverse operation of the access port is that when the tagged traffic, like let's say here it's tagged with the tag 3 or the blue tag, when it leaves the port, the access port, the tag gets stripped and it is delivered to the destination unmodified. So how it left, the shape in which it left this computer
Will be the
will
same.
be the same when it arrives to this computer. Some computers don't like tag traffic, like for example if you don't configure it here that way and the tag stays on the Ethernet packet, this computer will say I don't like this format and can silently drop it. So if you don't configure it properly on both ends, again you might lose the traffic. So yeah, if it is untagged, you should keep it untagged. And the next type of the port is the trunk links. As you can see, some ports can allow different types of VLANs to go through it. Like in that case, we have red and blue going through, and here we have 3 colors going through. These are special links that basically allow you to kind of pretend that you have 3 different wires running through the same wire. So in that case, it kind of packs red tags and blue tags into one wire and it goes to the next switch. Again, it is very important to configure both ends, such that if you configure it red and blue here, you should have it in here. If you have only red, what will happen is that the blue will go in here, will get out of it, go through the wire, reach the switch, he will look at it and say I have only red here, so I will drop it, and traffic will not go through. So throughout the whole network, everything should be configured properly to propagate your traffic. So everywhere on this port you should have blue, on this one, on this one, on this one, on this one, and that one. And the last type, which is kind of confusing, but we will be using it later in our labs, is the hybrid links. They combine properties of the access port and the trunk port. How they do it? Basically they look into the packet, and if it is already tagged, for example with the red tag, it just gets through and switch doesn't do anything to it. If the packet is untagged, like a white packet comes in, what switch does, he assigns the blue tag to it, and everything, all untagged traffic will be tagged with blue tag. And after leaving this hybrid link, basically we'll have red and blue traffic going through. The inverse operation is interesting too, since it passes the red traffic unmodified. What will happen is that, yeah, it basically will send it with a VLAN tag on it. But if it notices that the traffic is tagged with the blue tag, it will strip it from the blue tag and deliver it completely untagged. And it's usually called PVID, basically. So when you assign these VLANs to this port, you will have VLANs that are normal ones, like 1, 2, 3, and then you will have one special VLAN which will be working that way, that when it sees tagged traffic, it will remove the tag, and if it sees untagged traffic that way, it will put the tag.
So this can all be pretty confusing, but the last semester we found a pretty good analogy which helps people figure this out. So you could imagine the 3 types of VLAN ports like different types of bouncers at a bar. So you have access. Now let's walk through this one. So access would be the bouncer at the front of the bar. So after he checks your ID and whatnot, but his main job is to give you the bracelet that says you're allowed in. So each bar has their own colored bracelet, or each access has its own VLAN tag. And so when an untagged packet, someone who doesn't have a bracelet on, gets to the door, the bouncer is responsible for giving them the bracelet. And then he can do whatever he wants in there. But the bouncer's job is also, when someone's leaving the bar with that color, with that bracelet on, then his job is to take it off. So that's sort of what access does. Access is the bouncer. who gives you a certain color when you don't have one, and who takes it off when you leave. So either way, when you're outside the bar, you have no bracelet on. That's Access's job.
Yeah, additional things to it is that if you already have the bracelet which is different color, like the bouncer is the green color, and you show up with the blue color or yellow one, he will not allow you to go through.
Right.
Yeah, that's how the port works.
Right. And so then we have trunk. So trunk lets all traffic forwarded through the port if the trunk is allowed to have those VLANs pass. So here we could see examples. So I guess this would be the bouncer inside the bar who lets you go from one part of the bar to the other. So he'll check your bracelet to make sure that you have a color that's allowed to pass. So he sees your bracelet, he looks on the sheet that says, yep, you're wearing red, you're allowed to pass. You're wearing green, you're allowed to pass. You're wearing blue, you're not allowed to pass. But then, as Dr. Dogli said, on the other switch, on the other end, there's another bouncer who checks you as you're coming in, who's making sure that you have that color bracelet on. So you have to make sure that you configure both trunks. And then the last one is the hybrid. So this is both. This is a little bit confusing, but essentially it's this bouncer's job. So he has a list of VLANs. He has a list of bracelets that are allowed to pass through. But there's also another number or another color he has, and that color says, if you're coming in and you don't have a bracelet on, I'll give you this bracelet. Mm-hmm. At the same time, when you're leaving and I see that bracelet on, I'm going to take it off. So that's sort of how this works down here in this example. So here the bouncer would, he lets the red bracelet pass through, no questions asked. But if he sees someone coming in who doesn't have a bracelet on, he'll give them a blue one. And if he sees someone with a blue one leaving, he'll take it off, and then they won't have a tag when they leave.
And again, if there is a competing bar, person shows up with a green bracelet, right? He will not allow it to pass through. And since he sees it that he is not kind of untagged yet, he knows that this is competing bar people. He will not allow it to pass.
Right. Yeah. Okay.
And I guess this is the final interesting thing about VLANs is that you can actually propagate it inside of the computer. So what you can do is that if you pack several networks into one wire, you can deliver it to the computer, and then you can configure computer to actually do the job of the switch and separate those networks himself. And it literally looks like you have 4 different network cards in your computer. So physically you have one network card, one wire coming into your computer, but inside of the computer you have 4 separate networks. Like you inserted 4 physical cards and you ran 4 different wires to different places in your network. And it is especially useful for servers, firewalls, when you have just one box and you don't want to put so many interfaces in it. You just want one fast interface and virtual network interfaces. And you will be doing this setup in the labs quite a lot. VLANs actually quite useful technology, not also to separate networks by the way you configured it, but also by the types of traffic or to where the traffic belongs to. So if you separate it by port, you can say
SSH or...
no, it's actually different. It's like where you stick
the physical...
Yeah, the original idea. Then you can do by MAC address. So what you can do is that someone who has laptop and he moves constantly through your building, but he is the same developer who likes to sit next to different windows depending on the time of the day. You want him to be on the same network all the time, so what you can do is to assign his laptop's MAC address to a particular VLAN, and whenever he plugs his laptop, he will blend into the same network and probably will get the same IP address. Another thing that you can do, you can segregate traffic by protocol, so you can say that voice traffic will go through VLAN 2, and because of that you can later configure it to be high priority VLAN, or you can deliver it to more expensive channel which gives you like less delays or you can route it through satellite channel. Basically, switch allows you to separate it and deliver it with special privileges. At the same time, you can, of course, configure something which will be delivered, like if there is space remaining, like FTP, you can take it out and say lowest priority. If there is something going on, just don't do FTP at all. That's useful stuff. And I guess that's it for this lecture. In the lab, you just try to configure VLANs, separate the computers, and try to learn it literally by heart, because the next 5 labs, I think, will rely on it a lot.
Right.